Good evening, ladies and gentlemen. This is April O'Neill from Kickamuit Middle School, and I'm here to talk to you about how to use algebra tiles. I have some helpers here today. Sir, what is your name?
Donatello.
And what is your name, sir?
Leonardo!
Okay, so we have almost the whole Ninja Turtle gang here to talk about algebra tiles. So just to refresh your memory, you see the picture of the algebra tiles. We have the red tiles, which mean they're negative, and we have the green tiles, which mean they're positive. So there are two types, there are two ways you can use the distributive property, and the first way we're going to talk about it today is how to expand expressions. And I'm going to explain to you what that means. So, look at the example. 3 times the quantity of x plus 2. Okay, or 3 times the quantity, no, never mind. I won't talk about that now. Anyway, this means that we have 3 groups of x plus 2. So let's think about that in terms of the algebra tiles. Okay, Donnie, will you please help me? Can you grab one of the green x's and drag it? Alright, now, so that's 1x, plus I need 2 of the little ones, the green little ones. Yeah, you can talk. That is correct. That is x plus 2. Donnie, how many groups of x plus 2 is that?
1.
1. And I need 3 groups that look just like that. So let's circle. Can you circle that group right there? So circle the x plus 2. That's 1 group. I need 3 groups that look just like that.
Leo here. I'm going to show you x plus 2.
There's an x. There's 1. And there's, put it over here, 2. So that's another group of x plus 2. Can you circle that group for me? All right. Hey, Donatello, how many groups do I have right now of x plus 2?
2.
How many more do I need?
1 more.
Will you do? Good job. There's another group of x plus 2. Can you circle that? All right. There are my 3 groups of x plus 2. Now what we're going to do is we're just going to rearrange those tiles. Now I don't know if this is going to let me do this. Nah, I didn't think so. Okay, Leo, you want to help me? Can you put all the x's together and all the 1's together? Let's move them around. So let's move all the 1's together. Can you move the rest?
Yeah.
And Donnie, will you move all the x's together?
Yes.
Put them right over here. Okay, so now, instead of showing, let's see, the expression as 3 times the quantity of x plus 2, I can rearrange those tiles and say, all my x's, I have 3x, plus, I have 1, 2, 3, 4, 5, 6. So 3x plus 6 equals 3 groups of x plus 2. Those are equivalent expressions.
Uh-huh.
And that's the distributive property. Okay, so I want you to try one now on your own. So I want you to try 4 times the quantity of 2x plus 3. Now, answer question 1. Draw a picture if you need to. Regroup your tiles to answer question 2, your simplified equivalent expression. Pause this video until you're done, and then I'm going to go over it. Okay, so now that you've tried it on your own, this means 4 groups of 2x plus 3. Okay, so if I have 4 groups of 2x plus 3, I'm just going to show you one group of 2x plus 3. And I don't have, hold on a second. Okay, so here I have 2x, oops, I have one too many, so let me get rid of one of these. Okay, so here I have 2x plus 3, and that's one group of them. So I want you to imagine having 4 of those. So that really means I'm going to have 4 sets of 2x, and then I'm going to have 4 sets of these 3 extra blocks. So think of the bags and the blocks. I'm going to have 4 groups. Each group has 2 bags. That's my 2x's. And then it also has those 3 extra blocks. Oh, look, looks like a smiley face. Cute. Okay, so I know that I'm going to have 4 times 2x, right? So if I have 4 sets of 2x, that means I'm going to have 8 x's. And if I have 4 groups of those 3 extra blocks, that's 4 times 3, that means I'm going to have 12 extra blocks total, and I'm going to add those. So my simplified equivalent expression, so 4 groups of 2x plus 3 is equivalent to 8x plus 12. This is using the distributive property. Okay, so I'm going to refer to the algebra tiles to explain the shortcut to expanding expressions to create an equivalent expression. So when I say expanding expressions, that means what I have here typed in red. That means I'm going to write the expression without parentheses. So I'm going to change it from it having parentheses to it not having parentheses, but they're going to be equal. That's equivalent. That is using the one way to use the distributive property. So here you have, in this example, 3 groups of x plus 2. So that was the example we used from before. So the shortcut is that we have 3 of everything inside the parentheses. Okay, so I would also recommend that if there's a subtraction inside the parentheses, you use the sa-cha-cha. That'll just make things easier. So if I have 3 of everything inside the parentheses, my shortcut is going to be to multiply 3 by what's inside. So that's going to be 3 times x. And I'm also going to have 3 times 2. Okay, so I have 3 of what everything's inside the parentheses. So this gives me 3 times x is 3x, and 3 times 2 is 6. So remember, when we had the picture, we have 3 groups of x plus 2. So if I have x plus 2 3 times, I have 3 x's, and I have 3 groups of 2. So if you remember, we said that 3x plus 6 was equal to 3 times the quantity of x plus 2. So the shortcut is essentially take the number in front of the parentheses, multiply it by everything inside. And remember, if you have subtraction, make sure that you do the sa-cha-cha before you distribute. So in the second example, I used it with subtraction. So this means I have 5 times the quantity of 4y minus 7. So the first thing I'm going to do is I want to get rid of that subtraction symbol inside of the parentheses. So I'm going to change this to 5 groups of 4y plus negative 7. Okay, those are equivalent. So if I were going to use the algebra tiles on this, I would have 5 groups of 4y plus negative 7. And I'm going to bring those up to show you what that looks like. Okay, so you see here, this is one group of 4y plus negative 7. So I used a different long rectangular tile to represent y in a different color just because I had x's before. So these are a slightly different size. So when we use a different variable, all that means is that the length of the rectangle is a little bit different. And instead of the green extra blocks, they're negative. so you can think about that as taking away blocks from each set. Okay, so here's one set. So if I had 5 of these, I would have 4 y's times 5. And if you remember our shortcut, that's 5 times everything inside. So 5 groups of 4y. Okay, so that would mean to build this accurately with all the tiles, I'd need 20 y's. Okay, now if I go to the second part of my expression, which is what kids always forget, is that I have 5 groups of -7. So here are my -7s. I have 5 groups of those. So that means I have to add 5 groups of -7. So that's going to give me, that means I'm going to have a total of -35, and I'm going to add those. So when I expand this, I get 20y plus -35. So essentially, what I have here, let me see. I'm just going to do this here. So 5 groups of 4y minus 7 is equivalent to 20y plus -35. Okay, those are equivalent. You could also say this was 4y plus -7. It doesn't matter. They're both equivalent. And that is using the distributive property to expand. It went from an expression with parentheses to one without. And that's it for right now for using the distributive property and expanding expressions using the distributive property. So I'm signing off for tonight. This is April O'Neil. See you tomorrow.